Alright, hi guys, welcome. There's a little music in the background. Hopefully you can understand me perfectly well. Welcome to Virtual Day. Again, like I said in the intro, if you watch that, I'm going to go through this lesson as a video. There'll be time for you to stop and do some work in your notebook. I will be looking, or not notebook, but a piece of paper that you can then put in your notebook. I will be looking for that. I will also be looking for your email later today with the 4 key words that I say. Again, I will tell you when it's a key word. So for example, our first key word is earth, E-A-R-T-H. That's our first key word. Remember, there's going to be 4. All right, there we go. Let's take 30 seconds to breathe. All right, we're going to take 30 seconds to focus. All right, we want to be on task and focused, on time, not today. If you're there, great. So yesterday's mini thing, or session 141s, what are the layers of the earth? What is the relationship between depth and pressure? What are the 2 different types of earth's crust? What are the 3 different types of rocks? And what causes a rock to turn into a metamorphic rock? You can pause and answer those. I am going to go forward. Here we go. Layers of the earth. We have the crust, the mantle, the outer core, and the inner core. What is the relationship between depth and pressure? The deeper we go, the more pressure there is. What are the 2 different types of Earth's crust? Well, we have the ocean, the oceanic crust, and the continental crust. What are the 3 different types of rocks? That's ism, that's igneous, sedimentary, and metamorphic. And what causes a rock to turn into a metamorphic rock? Pressure. All right, here we go for today's learning. We're going to be talking about plate tectonics, boundaries, or evidence. We're going to have an elaboration, and we'll finish with the mini thing. We're going to be defining tectonic plates. We're going to describe the convergent, divergent, and transform boundaries. We're going to explain why the evidence that we have. And we're going to be looking at different vocabulary like subduction, boundary, fault, earthquake, and volcano. Our ponderings for today: how does the crust of Earth work, and what evidence do we have that once all the continents were together? We'll move on in a minute. All right, it is time for another key word. Our second key word is crust. Crust. So the first one is earth, and the second one is crust. And here we go. We're going to be talking about plate tectonics. So our world, our crust, is broken. Okay, it's broken up into different pieces, and we call those different pieces plates. And the way they move and interact, we call tectonics. So the whole thing is called plate tectonics. Here you see a map of all the different plates that we have. Pacific plate, Juan de Fuca plate, the North American plate, Caribbean, South American, Nazca, African, Arabian, Indian, Australian, Philippine, Eurasian, and the Antarctic. I don't think I missed anything there. I thought it was cool, this Nazca one, because I've seen the Nazca lines, and I was like, oh, cool. That's a thing. So we have plates, right? You can think of plates as like this big puzzle that fits together, okay? It's a moving puzzle, so this isn't a great metaphor, but close enough. When we go back to think about the plates, people have some misconceptions about how they move. Some people think the plates are on top of the ocean and they kind of float. That is not correct. They sit on top of magma, and here we go again, that word convection. We have convection moving. That hot magma rising, replacing some of the cooler ones, going back down and rotating all the time. All right, and so because of this, our plates are moving. All right, when they move, there's a few things that can happen. They can collide, or they can be moving apart each other, and if it's near the crust, we can actually see it. This is called a fault line. This is, I believe, in California. So that's physically where two boundaries are meeting. The other places, the places that we can't see, anywhere two places meet, we call those a boundary. Okay, a boundary. At this point, I do want you to pause the video, and you are going to, in your notebook, you don't have to draw all of this map. Okay, certainly do not draw the continents. Just kind of outline a few of the plates, and then down here are the names of the plates, label. So I want you to draw at least 4 plates that are touching. So you could be in this area right here and just draw those 4 plates. You could be over here and draw some plates. Okay, so in your notebook, draw the plates and then try and name them. If you want to go back in the video and see what those names are, you can, but I will expect to see that in a piece of paper that you've done this. Again, pause now to do the work. I'm going to move on so I can finish. All right, so when plates meet, different things happen. One of the types of boundaries that we can have is when 2 plates meet and they're going together. We call this a convergent boundary. All right. Normally, what happens is one plate goes underneath the other. You can kind of think of this as like at the fronts, right? We always have the warm front go up and the cold front go down. All right, but these plates are going together, and one goes down and pushes the other one up. And what happens? We create mountains. We can also create volcanoes. All right, this is Mount Everest, I believe, in the Himalayas. And here, that's made by this plate here, the Indian plate, cramming into the Eurasian plate and pushing it all up. Again, this happens over a long period of time, hundreds of millions of years. So don't expect things to happen instantaneously. At least that's not what we think. Another type, oh, here you can see the ridge here. So you see the plate going into another plate and causing these mountain ranges to happen. So again, that's when 2 plates are coming together, and we call that convergent. Here, this is called the Mid-Atlantic Ridge. So this is underneath the ocean. All right, and this ridge is being formed every day. It grows about the size of about how long our fingernails take. So a little bit is added every day. So these 2 ridges, these 2 plates are moving away from each other. And what's pushing them away is magma coming up through and pushing them out. Okay, so again, this happens a little bit every day, but this is a divergent boundary. They're moving apart. If you want to remember these things better, do the hand movements. Okay, you have convergent, you have divergent, and then we have one more to talk about. This is where those fault lines are. We have something called transform, where you have the plates sliding next to each other. All right, when they slide next to each other, that's where we have those fault lines, and we also have earthquakes. So those earthquakes are caused when those boundaries are sliding next to each other, and there's that friction. Okay, so again we have, and this is like the 2 plates. So we have the North American plate and the Pacific plate, and they're rubbing against each other. Okay, and that causes that San Andreas fault, where that's why California, if you know anything about California, has so many earthquakes. So we have convergent coming together, we have divergent going apart, and we have transform going next to each other. So the next part you're going to be doing in your notebook as well. What you're going to want to do is you're going to write down convergent, divergent, and transform on a piece of paper. Like I've done here, this would be a good idea, and especially like using the arrows as well to show, to help you remember what's going on. So make sure you have those. And you're going to do a sort that we have on the next slide. So what is that going to be? Again, I would recommend pausing this video. Let me get my face out of the way. And here, this is describing actual boundaries. All right. It says what the boundary is and then what's happening. So your job is to go to read about the Mid-Atlantic Ridge, read what's happening, and then go back to your piece of paper and write Mid-Atlantic Ridge under one of these boundary types. And then you go back to the slide. East African Rift, read what's happening, and go back and do it. So you're going to put all 6 of these ridges, or sorry, of these boundaries into your notebook, sorted in the correct order. So again, pause this video so you can be reading that and putting it in your thing. And I'm going to go on in 3, 2, 1. So how do we know all of this is real? How do we know that the plates used to be together? Well, I'm going to tell you, and I'm going to tell you what our third key word is. Our third key word is fossils. Our third key word is fossils. So this is a map, okay, a simplified map of where we find some fossils. And as you can see, because we find the same types of fossils in different places, South America and Africa has some like this. We have in different places. Look at this all the way. Same types of fossils in South America, Africa, India, Madagascar, Antarctica, and Australia. This tells us that at some point our continents were all together. So that's one piece of evidence that we have. A second piece of evidence that we have is this map right here. This map is the seafloor's age. All right, so we can tell by studying it how old the seafloor is. So if we look at that example I talked about, the Mid-Atlantic Ridge, and we look in the middle, this is millions of years old. So we can see right in the middle, it's somewhere between 0 and 10 million years old. And then outside of that, the yellow's 50 to 60 to 70, all the way to, what, 180 million years old, near the coasts of North America and the coast of Africa. What's interesting is this is the coast of South America is younger than the coast of North America. Fascinating stuff. So this is another idea that we have, because this means that seafloor has been created from magma. All right, so it's been creating and creating with those divergent plates happening and all that magma rising up and becoming lava. So now in your notebook, answer that question. How do we know? Try to use a complete sentence. So it could say something like, we know because... Again, I'll just have it go and you can listen to the fun music behind me. All right, I'm going to move on in 3, 2, 1. And here we go. It's time to elaborate. Here are all the words that we use today. Here's the things that you can do. I will also expect to see this elaboration in your work. And I will wait the 5 minutes. All right, that's been 5 minutes, and your final keyword is giraffe. Giraffe. All right, we're doing the mini thing. I know you can't really work with a partner today. I guess you could. You could be texting them and stuff using Google Meets or something like that. All right, here we go. What are the giant broken pieces of the crust called? And I'm just going to kind of move on, so pause, so I can get this done and up before it's time. They're called plates. Plates. Number 2, we can use 2 words to name the place where 2 plates meet. What are they? There was 2 different words. We talked about where they meet and where they touch. And those 2 words are, in 3, 2, 1, they are fault and boundaries. Remember that fault is where the earthquakes are and where there's transforming happening. All right, what are the 3 types of boundaries? And also use arrows. So I want to see on the big thing those arrows. Here you can kind of be making mistakes. Again, this is our exploratory learning. Mistakes are requested and required. So draw those arrows. What's happening with the plates? Where are they going? With next to the name of each type of boundary. And I'm going to move on in 3, 2, 1. Yeah, I'm kind of digging that up. All right, so we have convergent, where they're coming together. We have divergent, where they're heading apart. And we have transform, where they're going next to each other. I guess it would be more like this. All righty. Question 4, name 1. Oh, no, that shouldn't be boundary. Hold on a second. I was name 1 tectonic plate, not plate boundary, plate. And so that was that giant map and all the different plates. So just one of them, just one. And here we go. I didn't write all of them. Pacific plate. Ooh. Nazca plate, African plate, Eurasian plate, Indian plate, South American plate, North American plate, a bunch of plates. All right, and question number 5. What are 2 pieces of evidence we can use to show the plates have moved or move? So there was 2 specific things I talked about. And here we go in 3, 2, 1. Those 2 things are fossils and the seafloor's age. All right, everybody, remember that email. Send it to me before 3:30 p.m. today. And then that means you are here, that you were present. If you do not do that, I will mark you absent. And then second, I will be looking for this work on a piece of paper that you give to me in your folder or you put in your notebook. All right, everybody.